Hi everyone, welcome back to my channel. Today we are going to unlock one of the most powerful secrets in programming Python, which is inheritance. But here's the things, inheritance, it's not just a code, it's a family. It's about creating digital family trees where children inherit let's say, superpowers from their parents. By end of the session, you will be creating entire family of classes that work together like perfectly orchestra. And by the way, after the next lesson will be, let's see, improving our last project, which is image processing class. And in this session, this course, let's see, well, this session is designed for completely beginner. So you have to understand basic Python, I mean classes. And if you are following us from the previous sessions, of course, I mean, I guarantee that you will understand this smoothly. So, and in this we will you will learn, you will master, I think, how to create a class families, making a children inherit parent powers, and also giving a children their own unique abilities. I mean, which is in program. And we will see what is the overriding and what is the super keyword, and how to build multiple inheritance. Okay, and if you like this video, please subscribe into my channel, like the video, and of course, if you have any question, just drop it down in a comment below. And before we code, let's understand inheritance. What with some, let's see, we all know families, and think of it like your family. So your parents give you traits. Maybe your mom eyes, your maybe your dad height, but you also are unique. You are also unique. You have, let's say, your own personality, your own talents. You didn't lose your parents' traits. You added to them. See, this is somehow a short explanation, and this is exactly how Python and inheritance work. So in a programming, parent class parent class is mom and dad. Let's see, this is the template, and the child class, which is called derived class or subclass, which is the inherited parent features plus add its own. And the attributes is family characteristic like eye color, height, maybe I don't know. This may be enough. And let's say this in in a in a magic, let's say in a code. Maybe why we need to use inheritance is to sometimes we need to avoid repetition. So you write some code and you would like to use it without any repetition, and also organizing your code so it's like hierarchical, and it will be, let's say, more efficient to anyone to understand, and also easy to maintenance. When you have something to change, you have just to change the specific thing. You don't need to touch the whole code. Also extensibility, so you can add any other types easily without changing any, let's say, the layout or the structure of your code. And let's start with this. Usually I'm trying to type, I mean, live coding, but because maybe this will be long typing, so I just write it here, and we have to just add some stuff here. So let's now, we see this is this is class called parent class, which is animal, and by the way, it's also called base class. And this, for instance, animal, it has of course init function, and also eat, sleep. And for the child class, we have a dog. So as you can see here, this is the class dog, and we have open here parentheses, and we add here animal inside this. So this is called inheritance. So this one here, dog, inherit from the animal. when we add this class here, the outside one, is inherited the behavior of this class here. And if you see here, we have nothing to do with the class, with the doc class. And I would like to show you when I create, let's say, a doc object, I can use these functions here. So let me just create it here. We can just create it together. So let's say generic animal is called animal, and we call this, let's say, generic. This is let's see general animal, and now we need to see dog one is equal dog, and the name of the dog is, let's see, I don't know, Bobby. Let's just say like this, and let me now print some parent animal. So if I see print uh, generic animal dot, let's see, 8, and also we need to print as well, which is sleep. Let's see, sleep. And this is for the generic one. And as you can see, this object here is created from the animal. Now when I see dot eat, it will try to call this function and returning the name, which is, for instance, generic is eating, and also sleeping, generic is sleeping. This is, let's see, to see it here, I have to select the kernel, and you can see here generic is eating and generic is sleeping. Now let's see here, we have our, and you can see, of course, the after initialization we have to print this. That's why we have seen this animal generic and poopy created. Now let's try to use the d1 or dog to call some function which is, let's see, are not listed in the dog class, but it's the in animal class. Because it's inherited, it will we will be also to use it. So let's see, print. Let me just copy this, maybe it's easy, and I can just change this one. Let's see, d1. By the way, if you would like to change many lines in your code, you have to press uh, Control D and try to do it several times. It will select the the words. Let me just show, maybe this is a trick that could help you. Let's see, run. I mean, I can just copy this. Let's see, here we have, and you have runtime here, and you have to just hit Control D, and you can see with every time I have to select this, and you can just change it with one line, with every in one line, or let's say simultaneously. And you can see, for instance, we can just delete it and add here. So this may be just a trick, so it could increase your productivity. Maybe it's not relevant for here, but I like to see it. Okay, so now we see here d1 is 8, and as we said, dog has no functions here, but again it will try to use its parent, which is animal. So if you see here, try, and you can see Bobby is eating and Bobby is sleeping. And let's see, for instance, uh, see somehow this one here, for let's see, to see the 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 type, the instance. So if I see now print, let's see, hmm, d1 is a dog, and also here we can see is is instance So is instance d1 and dog. So now this one here is instance. It's I have showed you in the previous videos, and this instance is check if this d1 here is a type of object. Let's see class dog. If true, it will just say yes or no. And let's see now dog1 is an instance of animal. Let's see animal. So now dog is an instance of animal. Let's see. I'm expecting this one should be true, and of course this one will be true. Why is should be true this one here? While D1 is a dog, but it's still animal because it is inherited from the animal. And you can see here D1 is a dog. Okay, let me just make it clear. He is a dog and he is animal. And you can see now if you remove this, just maybe you don't need to have any inheritance. So now you will get here some errors because this one is has no functions. And you can see here Bobby, you try to create a object which has no initial value, initial function is this one here. So that's why we'll give you error. And if in case it has initial, it has no age and also no sleep. This is just the power of inheritance. You can see now Bobby has is a dog and also animal. So as you keep buoyants, the class dog animal, it means dog inherits from animal, and also dog get all methods from the animal automatically. I mean, you didn't need to write all of these methods, eat and sleep, inside the dog. It will be inherited automatically, and you can use it directly. And also you can see here, even with pass, dog still has the same functionality of animal. And maybe this, hopefully this is clear, but if it's not clear, I mean, as I promised, next video will be about updating our class, image processing class, and it will be, of course, more clear. So now let's see inherit. So as you can see here, the dog class has no attributes. I mean, has no methods or attributes. Now we can add inherit methods and also attributes. No, this is the next. It's the next section, which is adding a new methods and to the child. And you can see here inheritant. It can also inherit all of these functions and also inherited the attributes as well. And let me now add these. So then car can also inherit everything from vehicle, and also motorcycle will be inheriting all features. And I mean, you can see here with only 2 lines, I can use the same features here. And let me now just add some output, somehow printing. Let's see, print. Let's see, for instance, here it's the let's see. Oh, without this comments. So let's see, print. Oh, first we need to create objects. Let's see, my car. My car is, I have created a car, and as you can see here, the car has no parameters. I mean, has attributes, but I can still use the brand and also year. So let's see here. I can see car. It maybe Volkswagen. Let's see, Polo, and also the year of 2020. This is, for instance, my car, and this is, let's create my my bike, and we can see here moto motorcycle, and let's see here we can see Honda, and also the type, let's see CBR and 25. It's new. And if we see now the car operation, we can see print my car dot get info, and you can see this get info. It's in the vehicle class, but still I can use it as well. So you can see now I'll just give maybe he get start, and also let's see get info as well, just to see the status of the running. And that's so you can see here running is when you create, let's see, cycle in the beginning, it should be it's not running, but when it is start it will be true, and if it's stop it will be false. This is the difference between the this class and the other one. And if we see here, we can see Polo is created, Hyundai is also created, and when we see print my car, my info, let me, yeah, this will be, for instance, Polo status has stopped, and when I see it start, and then it's printing this Polo is started, and the next line will be starting is running. So you can see it has still have using the state of the vehicle class, let's say parent class. And also for the bike motorcycle, it's the same. If you just change this and try to change this, or maybe add it here and try to run, so you can see it's still using these functions while there's no functions here. Okay, so now children also can, let me just go with this. So all attributes are inherited. Let's see, brand, model, and year is running. All methods also inherited. Each object has its own separated attributes. Because here, when I create now my car 2, and let's see BMW X5 30 25. And if you see now, if you just print my car, we can just change one line as we have done it to, and change. So you can see each object, or each object, yeah, has its own separated attributes value. During the initialization, it will save the initialization, and also constructed is also inherited. So that's why we have initialized the value brand, model, and year. And also multiple child class can be inherited from the same parent. So you can see I have this car, it's inherits from vehicle, and also this motorcycle is inherit from this. So several classes can inherit from one class. Let's see just without multiple inheritance, just to understand this for the beginning. Okay, now sometimes you would like to add a child stuff. So let's say sometimes the child doesn't just copy their parents, they also develop their own unique abilities. So now you can see here animal, it has the eat and sleep and make sound. Now you can see class has added some other attributes, let's see methods, and it's additionally to the to these methods here. It's not, let's see, removing all this, it's just add some other attributes, so that this help us to let's see reduce the redundancy of code. For instance, dog, it's 8, But because I already use it as a in the main class or the base class, so it's not needed to add it here or duplicate it here. And also for the same class here for the animal. And let's do some coding here. Let's see, booby is equal dog, and we have to initialize. You can see here name. I can call this booby, booby, and you can see biases. Let's see, it's a let's see, call this golden, and here retriever. Let's see, retriever. And the second object should be a cat, which we can call it cat1, or maybe with the name cause, and also we need this name, and let's see, German cat. Now I will now print the dog abilities. So let's see here, dog abilities. Sorry for the typos. But now let's see, print booby dot eat. So now see, this inherited from the animal. It's not in this class, it's inherited from the animal. So we can use it, still we can use it. And let's see now, we can also add sleep. We can also, it's also inherited from the animal. And let's see, now try to use its abilities. Let's see its own abilities from the class itself, from the dog class itself. But it's only in a on dog class. And by the way, you can see here the most common functions must should be in a base class, and the specific activities or behavior should be only on a specific, for instance, class. For instance, dog is bark, fetch, and also wagtail, and also here's mew and climb, and also pull. So you can see different activity, different abilities. And now let's see park, and let's see print booby dot fetch. Let's see ball, and also you can see this is, I think it's easy. Let's see, to wag tail. This is, for instance, for the dog, and for the let's see, for the cat we can also use the same. But let me just change this, and we have to see. So you can see now changing with only one hit, one type. And but we need to change something here. We have to mew me. Is it mule? Oh man, sorry, cat. This has to be cat. And here you can see meow, meow. And also here, let's see, uh, the cat also can climb, and also tree. So now let's just run this and see what will happen. And you can see I still have, like, what's this? It's not working. What is the error here? Tile. Oh, Yeah, sometimes copy paste is dangerous. And you can see I can still have using the inherited functions and also the dog its own functions. This is let's see, just to show you that we can add some abilities to the dog to the child class. So let's see, we add cat ability. So now the child class can add also their own unique methods, and this may be a key point for each function. I mean, for each code. And inherited methods plus the new methods, it will let's see, consider as a full functionality of the derived class. And each child class have a different additionally methods, as you have seen here. And also, okay, I haven't used this. So you can see, for instance, uh, print, and maybe if, let's see, just to see if the cat has some attributes. Dog, let's see, can bark, and if it will try to give us true if the function that let's see has has attribute. And we can see here the object we have created, booby, and also we can see bark. So this will print, I mean, give us true. What was happening here? Has attribute, and also, maybe it's just only a single. Okay, it's only a single quotation. And you can see here dog can bark. But now if I use this, and I can see cat, and you can see here witches and bark. This will give us error. Why? I mean not error, false. Why? Because the cat has no function bark. This, so bark, it's only specific for dog. It's not an animal. It's only on dog class. I think that's this is for the this function. And here, for the overriding parent methods, sometimes we wanted to change how inherited methods work. And let's see here. So I have here the animal class, and it has make sound, move, and introduce. And the dog here, it has the same function. Let's see, you can see make sound. And when you see the same function from the it's in the base class, and also in the inherited class, this means it's called override. So it means you will try to change the behavior of the function, of the original function. So now you can see here make sound, and here's, for instance, make generic sound. And here it's uh, is somehow working only for dog. It will be woof woof. And for the cat itself, for the cat as well, we can change the sound. So this somehow, when you have some functions, you would like to change the functionality of the parent class, you can use this override. Just call the function as it is and add your implementation. Okay, and let's see, and also here you can see bad, it has sound, but by the way, it's not needed to override all of these functions. It depends on which function, or let's say, is relevant for you. And you can see here move and introduce. And here you can see, for instance, bad, it's override only make sound, move, but introduce, it's still using the original one, let's see, from the animal. And that's the point here. And let's do some stuff here. And so you can see it introduces, not overwritten, it's used, yeah. So let's say generic animal, it's still there. And I can see animal generic, generic. Then booby is a dog with name booby. And we can also use a cat, let's say Max. We can call this cat as Max, sorry Max. And we can call this a bed, the third class, called, let's see, Tweety, or maybe Tweety is equal bed. Then we can see here Tweety. Now let's just make all of these objects in one list, and so we can use uh, animals. We can use a for loop to access all these functions. So animals, we can copy this, put it here, because this will be also reviewing the for loop and also the list and everything. Maybe Max, it's not. Maybe it's a keyword sometimes, because if you import now math, it will there's a conflict between this is maybe max value, but let's just try this now. For instance, for animal n animals, now we will try to print. I mean, instead of printing all for each object or functions, you can just put the for loop, and it will do the same stuff for you. So now let's see here. We can start with new line, just to make a, let's see, a separation between this, and we can add here animal dot name. Well, there's no name. See, it's not private, so I can access this. Oh yeah, so I have semicolon, I mean comma. Okay, so now let's see, I also can use make sound, make sound. Why is this? Make sound. Now we can also try the other functions. Let's see, move, and introduce. The last one, let's just introduce. Why it's not completing? Yeah, okay. I don't know why it's not auto completed, but anyway. So, oh man, I don't need this. Just only we needed one. So you can see Control D, and I can remove it with one hit. Okay, so now let's see here. I have the animal, and as I said, I back all the objects here. So this it will start with a generic animal. It will call the name, it will be generic, and make sound, it will be generic sound, and also move and introduce. So it will just print all of these in the animal. Now for the second one, booby. Oh yeah, I need to also to add this. And as you can see, Bobby and Max will try to call this make sound and move and introduce. The override methods. But Tweety, it will use his make sound and move, but introduce it will try to use the in the one in the base class. So let's see how this working. You can see here generic, make sound, and blah blah blah. And here you can see Bobby is run on 4 legs, and also as a loyal dog. And you can see only this one here, the most important thing, because all the other functions already override, or let's say modified in the inherited class. And for the animal here, for the Twitty, it will try to use the generic one. So this is method, let's see, method overriding, redefining parent methods in the child class. The child class takes priority over the parent class. So when you see here, when I try to make a make sound, for instance, with animal, for instance, animal dot make sound, for instance, Bobby dot make sound. This will try to use Bobby make sound, not the original one. So this is called the child method. And same method name but different behavior. Can override some methods and keep the others. This is of course. And the polymorphism, same methods called different behavior. This is called polymorphism, but we will see it in the next videos, upcoming videos. Now there's a super keyword. So sometimes, what if the child does not want, let's say, to completely rebel, and what if they wanted to say thanks mom and dad, I will keep what you taught me and add my own, let's see, tweets. This is somehow the magic of the super. So what is the super hit is doing? So as you can see here, I have an employee. This is the base class, and here I have the manager, which is inherits from the employee. But if you see in the init class, in an init function, I have to call the parent super constructor here. So why? Sometimes I have some methods here which I would like to use in for the manager, but it has to I have to give firstly the information, the basic information to the main class, or let's see the base class. And see, for instance, I have a get info, work, then get annual. So all of this, let's see, overridden. But if you see here, during the calculation, let's see the even the work, or maybe get info. Let's just start with this before the story. So here is initializing the attributes of the superclass of this one here. Now when I see a get, for instance, get info, I will try to use what is already in super and use the get info. So now I will use the get info of the base class. And the interesting thing here is sometimes you have here bonus. I will try to use the bonus what is already in the base class. Now I would like to, let's see, to update my stuff here. So you can see team size multiplied by 1,000, and it means $1,000 for each team member, and return the base bonus plus the manager bonus. So you can see it's somehow combination between this. This is the magic, let's say, of using sober. And when you have a class inherited from another class, to please don't forget to have this sober initialization. If you will use some attributes, or you need some data from the base class, as we have done it here. So since we need some data from the base class, as you can see here. So this line here is calling the get annual bonus from the base class. And yeah, so this is a manager and he's a developer. And uh, let's see, so adding some stuff here. Developer. Let's see regular. Let me just go write this and come back because it's already too much. It's already 40 minutes. Now let's see here. So as I have added this, and you can see each employee types, I mean each employee builds on the parent's functionality. The manager get, let's say, a bigger bonus, and the developer should, let's see, their skills. And this is due to the 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 super. So when you use inheritance, try to use the super to initialize if you would like to keep the behavior of the parent class. So as you can see here, what is the difference between this function? I mean, for instance, let's see get info here. The get info it's already in the employee class, but from the previous example we have seen we overriding the parent class, but to prevent this to keep the behavior of the employee class or the base class, we have using this super here in the in this child class. Let's see, and here we have also printing this, and now a key point here super called the parent class. So when you see super here, it's called the initialization of the parent class, and also it's extend the ability the functionality, not replacing. Keep in mind, without super initialization this here, it's let's see overriding, but with it's just extending the functionality. And this one of course called the constructor, and the common button get results. And here you can see here adding a child a specific while adding the child a specific features. It's also maintaining the parent behavior while adding some specific features to the file to the class. As you can see here, I have this developer here. I have the manager. Let's see the good example here. I have also you get the behavior of the parent class, and also in this function here get annual I have added some extra functionality to the child class, to the manager class. And the next step, let's see, is the next is multi-level of inheritance. So honestly I haven't used it, let's see, in my practical let's see in industry. I have worked with several years, but I'm just rarely, let's see, some cases that I have been using the multi-inheritance, especially in Python. And but of course, it's used heavily in C++. And you can see here, this is vehicle, and here motor is inherited from the vehicle, and now the car is inherited from this, and this class it's itself inherits from the vehicle class. So when you see now here, I think, yeah, when you see now, if you see this car here, it's a vehicle, it's a motorcycle, and also it's a car. So this is the multi inheritance, but multiple inheritance is somehow make it the program is maybe more complicated, and maybe I will just recommend you just try to make it simple, and if it's needed, try to use it. Otherwise, it's just adding some complexity to your program. This is my let's see perspective. I might be wrong, but yeah. And also, before we finish, let me just see views from some common inheritance traps. So you can see, where is this? Yeah. So you can see always try to call the super initialization function. So let's say, for instance, here you haven't called this super initialization. And when you try, let's see here, let me just comment this line here. And wait, please. Okay, and here's are two classes. One is bad dog, and one is let's see, a good dog. The naming is just to reflect the okay or not okay. So you can see here it's inherited from the animal, but without using this super initialization, the name and age. And when you see here, let me just copy, I mean comment these lines. And if you see here, I try to initialize the bad class, bad dog with bad and three and labrador. See, and here it's animal, but without initialization, without this one here, name and age won't be, let's see, initialized. And if you see now here, it has attribute bad dog, it has attribute, I mean usually in the animal it has name, but without this it will not be it will be let's see, false. And you can see bad has name false, and bad dog has age false. Why is this? Is only because of this missing, I mean this missing super initialization. And if you see this one here, after initialization, you can see now it's true. Why? Because we have used super initial. We call the constructor of the parent class. And do you know what is this doing? It's just adding 50 50 this sign here, equal, yeah, it's equal. And this is just to somehow if you would like to print some, let's see, many strings, but instead of just typing several times, you can just add the string that you would like and multiply by the number you would like to repeat. Okay, now the overriding is without, let's see, understanding. And let me just copy this. And you can see here uh, and add function here, it's in the class, in the calculator, right? And add, it's just replacing the, let's see, overriding the function itself of the calculator, and which means you will lose the history functionality. What is the history functionality? As you can see here, if you have a and b, you will just add these values and that's it. And the history is nothing, is empty, because here we have using empty, I mean history. Now if you see here, I have called this, try to call this e plus b and add it to the history. It will be added automatically to the history and show you the result. Let me just show you the result. So you can see bad calculator is history is empty, but the calculator, this one is has some values, or let's say strings. Why? Because we have the history here. This is just because you have replaced the add, override the add of the main class. And you can see here we have still have the function, but we have added super. It's like the previous one. Okay, and common mistakes for the inheritance, you might be forget the super keywords, and also overriding without a super, it's losing the parent functionality, as you have seen. And also, as I said, deep inheritance, it makes hard to understand, and I'm trying to avoid this indeed. Function, I mean multi inheritance. I try to make as much as I can to avoid the multi-inheritance, because sometimes inheritance might give you some, I mean, when you try to debug the program, it will not be easy to find the error. And also try to use super and keep inheritance, as I said, simple, and also document the relationship, make the inheritance. If you need the inheritance, try to make it. If not, you don't need it. This is the let's say the goal. And I think this is enough. It's I have seen 60 minutes, but it's 50. Okay, that's fine. Okay, so we are in the end, and I think hopefully you all get what is really important. And if you like the video, please subscribe into my channel, like the video, please. And also, if you have any question, just drop it down in the comment below. Thanks for watching, and see you next time. Of course, I will share all of this. And yeah, by the way, the next section, I mean the next videos will be magic methods, or called Danda methods, and is data classes. What is the class static and instance methods, encapsulation, polymorphism, abstract class, which is really helpful, and also what is the difference between composition and also inheritance. Thanks for watching, and see you next time.